Okay. Good morning, everybody, and you are welcome to the class. I want to believe now you can see my screen.
Yes, we can see it.
Good morning.
Good morning.
Okay, thank you very much. Okay. Good morning, everybody, and you are welcome to the class. I want to believe now you can see my screen.
Yes, we can see it.
Good morning.
Good morning.
Okay, thank you very much. Okay. Screen. Yes, we can see it. Good morning. Okay, thank you very much. Screen. Yes, we can see it. Good morning. Okay. So now we continue from where we stopped last time. It's how to learn machine learning and data science faster and more productively. This is under our issue important clarification series, clarifying towards making AI, machine learning, data science accessible, ethical, and life-changing positively for people. So with that particular theme of always let the data speak, follow the right process so that we don't mutilate our data, so that the data that is so abundant, wasting away, can be able to give us insight. You can get the necessary insight from our data if we use the right perspective and the right framework. So we'll continue from where we stopped last week as usual. I always start by reminding us why you can no longer ignore AI and machine learning. So check out those 3-part videos, some of the intricacies, the reality of what we are facing these days, and where AI is and where it's likely going to be. So check them out. As usual, we always have this iterative machine learning model building framework where you are going to see the very simple, however, iterative process that gives room for you to correct whatever mistake you may have made. So you always have that opportunity to correct it again so that you don't have to get it right at once. You don't have to get it right at once. You can always go back. So when you start with your data, you make it ready for modeling. And then you go into the modeling stage, you can always go back. You don't have to get it right at once. That used to be the old school where people spend 60 to 70% of their time working in this place, doing feature selection, doing pre-processing. So many pre-processing to the extent that by the time you are done with your work, what you are having is no more data. It is already what I call mutilated data. When you do too much pre-processing, that may not be necessary. Pre-processing is good. However, what amount of it you really need depends on the data you are modeling and what you want to get. So that is why we always emphasize the need to use the principle of let the data speak. So when you do that, we have cases whereby the original data set will be the one that will speak for you. You don't even need to do pre-processing. The data is okay from the beginning. And in some cases, you need one or two preprocessing steps. One is some you need multiple preprocessing. That may not even be enough. You might have to do feature engineering, feature selection before you get what you are looking for. So it depends on the problem you are solving. So that was why we then had a particular thing we call the modified iterative modeling scheme, modified iterative machine learning modeling framework to support let the data speak. So once your data is in, you have it in the modeling stage, then you can always go back here. What do? Hyperparameter optimization. Changing the algorithm. Try different algorithms because there's no free lunch. There's no single algorithm that works in all situations. So keep changing them. Sometimes you may have to make ensembles, which is more powerful when you use the power of the crowd. Let them jointly take decision. Also hybrid, and also other algorithm enhancement that we can do. That is at this stage of trying to get, all we are looking for is performance improvement. Sometimes you may, stopping them may not be the solution. You may have to go back, do feature engineering, reduce the data down the sampling, like record down sampling. Can use clustering to identify rogue data samples and kick them out. You may do attribute down sampling. So where you have feature selection, you may also do feature reduction. So where you have things like PCA, principal component analysis, to kind of transform your data. We call it data transformation. Some of others here also, you have to do normalization of the data, log transform to reduce skewness, discretize, construct new attributes. So many things you can do under the feature selection option. Sometimes you may not have to stop it. You may have to go here, finally, prepare the data. The missing value is there, outlier is troubling you, identify, reduce noise, and type conversion, test cleaning, data consolidation. Maybe the data you had is not the appropriate one. Get more data, integrate them together, aggregate them together, and host of other stuff you may do. You may have to come here just because you want to improve the performance. However, by just getting the data, you cannot tell where in this journey will I get the best result. See, but the industry you can do to your data is to just send it through so many preprocessing. At the end of the day, you have a mutilated data that is no more speaking for you, that is no more communicating, because you already removed the ingredients that will have assisted the data to communicate well. So we say start from the beginning, have what we call the multi-channel pipeline approach, whereby when you run the original data, put the result down. Channel 1. Channel 2, do preprocessing, missing value treatment, outlier treatment. Every channel you have result. You got 92% here, but then 93% here. You get 85% here. You keep recording the result of every time you have new channel. So we call it multi-channel pipeline. Thereby, at the end of the day, you're going to have several options, then you can pick the one that is working for you. This is what we call letting the data speak through the multi-channel approach, framework approach. Having said this, for those people, for the sake of people who just join us or recently, don't forget, we are already recreated courses for you. Check it out. This is freely available on our YouTube channel. So for those who joined us recently, struggling to catch up, I can tell you, you can always catch up. We made the video so easier to follow. So check out those 3 videos or 4 videos. By the time you are done with them, you have a very clear understanding of what is machine learning, data science, and you can apply it in your own area of interest. After that, within 1.5 hours, you'll be done with these videos. They are not very long. So you are a very total grasp of what is machine learning and its family. After that, then you go to the practical. After watching the 4 videos earlier, it is time for you now to demonstrate practically what you learn. This is where you're going to check out this video again, where you're going to have practical demonstration in weaker environment. You download that software. It's well explained in these videos. 1, 2, 3. Download Weka. It's free software. The data set is also made available for us, or you can have any data set, upload it, partition the data into training and testing, use your modeling. You can also fill it within everything. The entire video and this practical one will take you less than 2.5 hours. That's 2 hours, 30 minutes. You can do it in just one afternoon. Then you can see that you built your first model within just 2.5 hours. So you are coming up, you are becoming, okay, this is how to use it. Then you start building your confidence. While watching those videos, please note down some of your concern or clarification you want to make. This is the essence of this weekly program. So you can ask questions that they clarify whatever confusion you are having. In situation whereby you got stuck and you really want to get relief quickly, you don't want your learning to stop, and that stuff is not going to make you continue, that's fine. You can reach out to us. Private chat us, and then we'll be more than happy to support you towards getting your feedback so that together we can increase and then facilitate our people getting the right knowledge so that they'll be able to apply AI, machine learning, and data science in their own various field of interest. We always also want to tell us the different angles to solving problems using ML. To those people from diverse background, engineering, medicine, you are all welcome. See, social scientists, business administrators, irrespective of your field, you got covered. So check it out. Think of area that may interest you, that may benefit from this idea, and then run your first model there. Put it into writing, both research and in academic in research. Gone are the days where research has to be in university. Now we have R&D in companies. R&D, research and development. Some of the top companies, they have big centers that are even bigger than some universities, where they put the best of the best brain to do research for them. So, so those say, I'm not a researcher, so I'm not an academic. Everybody needs research these days. If your company must be competitive, you need to know what is going on. And AI machine learning can assist you to have an idea of the market, what the market may say, 1 or 2, 3, 4 weeks ahead, so that you can plan accordingly. To those people from computer science related background, you try to solve problems for people. Think clearly and brainstorm about areas that may be in dire need of improved outcome, and set yourself in to help by coming up with machine learning solutions, AI solutions that can support people, that can facilitate the life of people, like in medicine, make diagnosis easier. You see, doctors are always overloaded, overworked. What if we can build a system that can ease their affairs? Instead of hundreds of patients waiting for doctors, a nurse can just use machine learning to quickly do a pre-screening for them. The more critical one will be identified. These are the people that will go to doctor. Some people just need to go and take their drugs and go back home, thereby making life easy for both the doctors, the nurses, and also even the patient. You'll not be waiting when you don't really need to do this to see a doctor. So, and so many other things. Imagine having to have so many advantages we can have. In the economist line, I mean, you want to be able to tell us what is the reality of the market, you know? So what's going to be the prices of goods in some places, or you want to look at the effect of poverty, socio-cultural development and poverty. Is there any tie? Poverty and migration or immigration. So many studies have been conducted these days that are making use of machine learning to make it better. People have been using it before. Usually we use econometric and the likes, but today with machine learning, we can do it even more with higher accuracy and trust. We also made it very clear to us that we should always remember, always let the data speak. Start with raw data set before applying too much preprocessing. Always use the iterative process idea. Remember, machine learning is not a dogma. Try different algorithms and options. So one algorithm is better. SVM is a very excellent algorithm, but yet you don't say it's the best. We've used it in a lot of our applications successfully. However, at the same time, we've had scenarios where support vector machine couldn't model the data comfortably for us. We have to use other simpler algorithms. So there's always a principle in machine learning modeling. Start simple. Let us remember that. Start simple. Because this day we are in the age that everybody just wants to use deep learning. Deep learning. No, everything is not about deep learning. You may miss the insight from the data set if you do that. We have scenario whereby deep learning was not able to get the message from the data. The simplest KNN neighbor, KNN, naive Bayes did the work for us. So this one getting like 83%, while this guy is getting like 98%. Will I just go for the name? Because it's a big name. It's a new method. So we must use it at the expense of, instead of getting better result? No, that's not machine learning principle. Machine learning principle say, start from simple. Use simple algorithm, KNN, decision tree, and then gradually move towards more complicated ones if these simple ones are not making it. And sometimes you start trying to say, okay, can I make hybrid or ensemble? Let them gather together and take decision for me. Maybe you get the better result. This is very important. However, I stress, if you are dealing with problem that has to do with videos, images, text, and text, then deep learning is a good point for you to call, especially at the beginning, because it has the ability to extract feature for you automatically without human intervention, unlike the classical machine learning. For support vector machine, for KNN, we have to have the data ready in an Excel format. You see, or in the format that the platform allows. Somebody must have extracted the data, either manually or using computer, whatever. Even video, somebody needs to extract the video features, then send it to a SVM. But deep learning has that capability to extract the videos, images, text automatically. However, the moment deep learning extract the data for you, the features, let the data go into deep learning classifier, and also go to standard classifier like SVM. Compare the result. Because the power of it is in extracting features automatically. Once the feature has been extracted, then it can behave like any other classifier. Send those extracted features to support vector machine. Let deep learning also do the classification for you or regression, and then check the result. Maybe this one is getting 92, this one is getting 93, or this one is getting 98, and this one is getting 95. We've gotten that in experiment, whereby after using deep learning to extract features, we noticed that support vector machine, when we provided them with that, they perform better than the deep learning itself in the actual classification. So you use algorithm based on their strong points. You see? So this is very important and in line with principle of always letting the data speak. If you just jump at the very top, oh, there's an algorithm that is ready now. It's called CNN, Convolutional Neural Network. Oh, it's great. You may be wrong, because in your own data you want to model, that algorithm that is very popular may not work for you. So I want us to take note of this. So you take the next step based on what you can deduce from the data modeling outcome so far. And this is where experience matters. You need somebody to guide you. Once things get really tough, you are not getting improved result. Speak to experts, consultants who are very experienced, they can guide you. It may just be something minor that you are missing so that you'll be able to get good results. So there are other learning resources also that we've also created for us, like the Let the Data Speak itself. You can get it from here. So, which is a new book, so that we're saying stop guessing, Start letting your data guide real decisions. It's a roadmap to mastering machine learning, data science, analytics in the smartest way possible, without confusion or costly mistakes. So I said a must read for students, professionals, and anyone serious about data science. So we encourage to check it out. A lot of people are benefited from the information they are in. God be the glory. We also have machine learning made simple. So for those people who don't like to visit YouTube channel, we have some people who don't like YouTube channel. I mean, their preference, they want well-curated courses. The same videos, 7 videos I told you earlier, these videos, which are already available in our platform, these 7 videos, these are the videos also that are available in this course. But for those who like it to be in course form, you can check it out from Seller. You can also get it from udemy.com. You have the link there, where you can build machine learning model within 2.5 hours. It's a crash course using Weka, so which is perfect for beginners and professionals. So you go for the free one, which is okay, or you go for the courses, whatever option you like. Then we have also the writing machine learning based research papers, a new course also. How can you write your first research paper as a researcher using machine learning and data science approaches? You also can get it from Seller and also from Udemy. Yeah, so moving forward now, we also mentioned types of analytics. We started this already. Now we can move in. Types of analytics. So when you have a problem to be solved, the first thing you have to check is, which kind of analytics do I want to do? This is very important. This is a standard machine learning-based data science analytics modeling framework. You have to understand the business understanding, understand the data, prepare the data, exploratory data analysis, data modeling, model evaluation, model deployment. We call it the data science type cycle. That's a simple way. However, this one makes it even more elaborate. Here we call it machine learning-based data science analytic modeling framework with feedback mechanism and the analytic option. So once you understand the business, the first thing you have to answer is, which kind of analytic approach do I use? There are 4: descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. You need to decide these 2 first. To make it clear for you, we had it here. See, these are the 4 types. Of course, new ones are coming recently. We'll introduce you to you later. The one we call visual analytics. But for now, know about these 4. Descriptive analytics, where you are asking the question, what happened? Compulsory for any work you want to do. It is in the past. It's a past tense. We call it hindsight. It has happened. So what can you do with it? See, it has happened in the past. So what can you do with it? So what really happened? This is why you draw graph, you use visualization, you find the main mode media of the data set, how many male and female are patronizing your places. So many analytics you want to carry out there. We call them descriptive analytics. Later, we're going to have a look at them in detail. The second one is, why did it happen? Which we call the diagnostic analytics. Diagnostic analytics. Why did it happen? Why did it happen? See, this is very important. Why did it happen? Yeah, see the same thing that is represented there. Call it the analytic capability. And the good news is that, you see, as you are going up, the value is increasing, and the difficulty is also increasing. So meaning that this is difficult compared to this is difficult compared to this, and this is difficult compared to this. But as you go up, the value you are going to get is increasing. So that is why the difficulty you are going to encounter in solving this type of analytics is really worth it, because the value also is going to increase. A company that is running predictive analytics will have an idea ahead of other company that is not handling it. So if you stay at this level, it's fine. You understand what has happened in the past. Then you try to use your own human ability to see how you can prevent it, or you can enhance it if it is something that is good. You see? That's the descriptive analysis. What happened? That's what you're answering. What really happened? Once you understand that, diagnostic analysis will help you to be able to work on what you see there, you have detected. Diagnostic analysis say, why did it happen? Why is my sale down in March and up in April, and then again down in May now? What is happening? Why? So diagnostic analysis will help you identify what is responsible. That is, why did it happen? We call it, here we started having insight now. We start having insight. This is hindsight, because you cannot avoid your history. You need to understand your history, where you are coming from, before you can make progress. See, that is why descriptive analysis is compulsory for everything you want to do. First of all, analyze your data that is coming. Though you cannot do anything to the data set, it's already produced. It is past tense, but you need to understand your history so that you can plan well and avoid mistake, while you keep the good news there. You keep them coming always. So even positive things, when you achieve positive, you also run diagnostic analysis. Why did it happen? Why are we, what is the reason for making such huge sales in April? Then we'll be able to see, oh, this is the reason, so that you can keep it up. And sometimes also, if something goes wrong, then you also run diagnostic analysis to have an idea what it did, why, what really made it happen like that. That is what we use diagnostic for. That is insight. Try to have an insight to what really happened and why it happened. Then the next is what will happen. Predictive analysis. You see, this is sandwich between its foresight, why did it happen, and prescriptive analysis. What will happen? You have an idea that, oh, it may rain tomorrow, so that you prepare for it. A customer that will visit our shop next tomorrow will be very high in so branch. Can we mobilize some staff from branch A to branch B? Because the prediction says there will be less customers in A, but there will be more customers in B. You don't want your customers to be waiting too much so that they don't complain. So you move some staffs here, because for now you don't have the capacity to recruit more. Move them here to this place. By next few days, it's also predicted that A is going to have a lot of customers. Then you can move also from here to here. That is the power of having an idea of what may happen in future. It's not soothsaying. It's not magic. It is data. That's why we say, let the data speak. Based on what happened in the past, for the past few years, we have an idea. Then we can extrapolating and then be able to have an idea of what may happen. Imagine being able to predict that your staff is going to be absent tomorrow from job. You can reach out to the staff and prevent him or her from absenting himself, especially the very important one. You see, you run what we call absenteeism predictive solution. The manager just run it in the evening and notice some people have been identified. Oh, this guy will be absent tomorrow. Then you put a cost to him. Hey, Mr. Man, how are you? Where's your family? Tomorrow we'll have important personality customers coming. Can you come very early? Meanwhile, I was planning not to come. So you are going to break that absenteeism. So it's already been used. Customer shun. You have an idea that a customer may run away. So that you'll be able to prevent him from running away. Telecom companies are using it a lot. Telecom companies are using it a lot. See, once they notice that you are no more buying credit, you are no more buying data, they can start giving you free data, free airtime. Buy 10 naira airtime and get so huge amount of airtime. Because the system already identified you that you are likely going to leave the company. You are going to switch to another provider, service provider. You know, a lost customer is a potential enemy that will badmouth you. It's not just you are losing one person. You may lose a lot of customers through that person that is leaving, because he may move his family away. His family also are connected to other people. Before you know what is happening. So losing a customer is just not one person you are losing. You are creating more people that way badmouth your company. So we prevent it by running what we call the customer shun predictive solution. So you have an idea that a particular customer may run away so that you can take action to prevent them from actually going. Sometimes also you have, how can we make it happen? Prescriptive analytics. Prescriptive analytics. Sometimes you desire a particular characteristic in a product. You want to achieve a set goal. You can ask the prescriptive analytics to do that for you. How can we make it happen? You want to achieve so number of X sales and then zero resignation in so you set up a particular set of goals. Then you can run out prescriptive analytics to do that for you. So it will tell you, if you want to achieve this, your set goal, then you do this, you do this, you do this. And as you are doing them, you'll be getting the goal. That is prescriptive analytics. Tells you what to do to be able to get what you are looking for. And those are the 4 main types of analytics and their corresponding can we properly frame questions and the machine example. The descriptive analytics, what happened, like monthly sales dashboard. We have a monthly sales dashboard where things are arranged for us. You can see, you can visualize it. The dashboard contains branch A is not doing fine, branch B is doing fine. The manager start to analyze it, look at it. Then once you know that, then you'll be able to say, okay, anybody who purchases A always purchase B. So the next promotional sale, they are going to make sure that A and B are not put together in the same place. You put A here and put B here, because anybody that purchases A will look for B. You separate them in the shopping mall. So when you buy A, you'll be looking for B, moving around. So while you are moving, you see a lot of promotional sales, new arrivals, so that you fill your cart before you get to what you are looking for. That is techniques that people use after understanding what really happened in the past. They run the analytics and they can be able to take decisions. I will encourage you to visit their shopping mall, not just pick what you are looking for, but go around. While looking for the second product, because they already identified that whosoever purchased A will likely purchase B. Ideally, they are supposed to put it together so that you can pick it and go back, but they don't want you to go back immediately. They want you to go through the shopping mall so that you can see new arrivals. And even if you are very disciplined financially, your family members with you, your children will keep picking things. Oh, Dad, I want this, I want this. By the time you get to the next item you are looking for, your cart is full. That is what the business people are using. Then when you see a product C and D, people like this, but nobody is buying this D. And it's getting closer to maybe expiration date. Then you buy C and get D for free. Buy C and get D for free. You put them together, C, D. Meanwhile, C maybe was being sold for 4 naira before, whereas this one go for like 3 naira. Now they're going to make this to become 5 naira and then give one for free. So you think you are buying it for free, you are not buying it for free, you are paying 1 naira for what you don't need. That is the power of analytics for the business people. So the power of analytics means they want to make sure that the goods are sold because they have an idea of what really happened. History is very important. You cannot ignore our history. Why diagnostic will make us to say, why did it happen? So we want to investigate why sales drop last quarter, why it improved this quarter. Based on that, you may be able to predict what is going to be the sale next week or next month. That's why you have the predictive analytics, what is likely to happen, then predicting the customer shown as an example, and describe that prescriptive, what should be done. It's more of a route optimization for logistics. I want to move some goods from here to there. What do I do to make sure that I use the least cost possible while reaching my customer in a timely manner? These are the 4 major types of analytics. We'll be looking at them as we are. So this is historical. We call it hindsight. This is insight. This is forecast. And this one will give you the action you're going to get. The case may be. So because of our time, so I believe we are going to call it a day at this point in time. Once you have your data set, most data sets, you have to do this. Descriptive analytics is a must. Even research paper, you call it description of your data set. You have to provide it. where you get the data source from, what is the data size, what's the number of samples, the main, the media, all those descriptions, they fall under descriptive analytics. And then we share a document in our platform a few days ago. So how to write machine learning-based research paper. We give that one for free. Just take that document. You just start doing your experiment and start writing. It's already well formatted for the usage of people who may benefit. For diagnostic, depending on the problem you are solving, you may want to do feature selection to identify what are the most important compounds in the experiment you are doing. You have data in the past, bring them in, let them come and speak for you. Let them come and help you take blind decision. Imagine people who want to have an idea. You want to predict something. Usually there's a compound. You stay in the lab for like 4 days before you get the outcome. Imagine having a predictive solution, train it on your past data, and then just predict the compound you are supposed to see in the lab for 1 week, or even 2 weeks sometimes. And then you compare with what you have in the past. You'll be surprised. Rather than waiting, you can get it done quickly. Just like it's revolutionizing the medical field now. So when you have to culture a blood sample for like 4 days and somebody is critically ill, train a predictive model from past data and be able to predict which type of organism is being cultured. Instead of waiting for 4 days before you start treatment for the patient or using a random drug just to keep him alive, you have an idea of what is in there because of predictive analytics. And so many capability that we can explore in this kind of system. So again, because of our time, I think we're going to stop here to give room for your questions and answer. So thank you very much for listening. And we are going to now take a couple of questions as the time will permit. Now we continue from there. So if you have questions, okay.
Good morning, Prof.
Okay, I have a questioner there. Now you have the floor.
Yes,
Good morning.
good morning. My name is Umulkhair Arama. I'm a fifth-year medical student at
Okay.
Ahmadu Bello University. Yes.
Yeah,
So
welcome.
I just started the course and I intend to use it for research purposes. So thank you very much. The course has been really explanative. Like I've been able to understand most of the things very well. So I just have a question.
Okay.
Please, what's the difference between because you said we can divide our data into the training data, validation, and test data. So what is the difference between the validation data and the test data? Or are they the same?
Okay. Thank you very
Yes,
much.
thank you.
Initially, when you divide your data, I hope you can see my writing. When you divide your data, we have training.
Yes,
Can you see my writing?
yes, sir.
Okay. We have training and testing.
Yes,
See, two major ways of dividing data. The first one, we call it the hold-out method, the hold-out method. This is where you divide your data into two. You use one for training, and you keep the other one for testing. This is called hold-out. You keep it away. Now, that hold-out method can now be done in two ways, depending on the size of your data. If your data is sizable, you have maybe sizable like 3,000 or more, 2,000 sometimes, You have training set, maybe 70% training set. You have testing set, which is like a 15%. Then you have another validation set. Validation set, another 15% of your data. You see, people does it. Though sometimes people use it interchangeably. They can call validation first before testing. They say we want to validate before the final test. Sometimes people use it interchangeably. That is fine. What they are used for, either validation or testing, is to check that the training is good. Because when you do training, what happens is this. You have 70% of your data. We have a label. We are assuming now you are dealing with labeled data set. Data set that has output. So I give to this is the hypothetical system of machine learning. So algorithm. So you have the input, X, and then you have the output, Y. So for example, we want to culture blood samples are sent to the lab in case of maybe infection. They need to know the exact type of infection. So they have to do the culture, and it takes time. And I'll say, okay, why don't you give me, you have samples in the past that have been cultured and you know the result. Bring those data sets. So you have the characteristics of this data. You have the characteristics of the data. So you have the characteristics of the data known already. So you give in the X and then the Y, the output. This output, the culture we found was also type of bacteria, or as the case may be. For this type, you keep giving it different samples and the system will be understanding it. Finally, to generate one hypothesis function, which we call F. That's why we say Y is equal to F of X. In training, we are looking for this F. Once we get this F, it's like a program. Subsequently, when we have new X that we kept away, which is testing or validation, we now give it to that F. We call it X prime. This X prime is not among the X we use for the training. This function will be able to tell us the output of this kind of culture. That is going to be your output. So once we check it for validation set, all the samples, we test it. Are they, we have the output. So, but we will not show the output to the system this time around. We are testing it, we are validating it. So this one, we check this. We now see that out of maybe 50 samples, 48 were correctly classified while there were 2 mistakes. That will be 48 divided by 50 times 100. That's going to be the percentage accuracy of that kind of a system. This is in the hold-out method. However, the second type of the hold-out method is when you just divide your data into 2. Training and testing. I don't do validation separate from, I only have one time. That is also fine. But the rule is make sure your testing set is never used for training. Testing set should never be used for training. In fact, when you are doing your hyperparameter optimization, you should not use your testing set. Some people make this mistake. They say we have training set and testing set. But when they train, they use testing set to check the result. During the hyperparameter optimization, it's not correct. Your test, because that's going to be a data leakage. When you have data leakage, it means your model already have an idea of the test set or testing set or validation set. We don't do that. So the testing set will be kept totally out of the predict. In fact, that's why some companies, some clients will not give you the final test, or after you train a test, they bring another one. In software development, we call it the final checking or testing, where the customer now will now use his own data to test what we have built and see if it's really working. See? But before you do that, you have to have tested it in your own site as a developer. As a machine learning engineer, you must have done that. So make sure the training set is totally different from the testing set. I never use it in the system before. The second type is what I call the cross-validation. When you look at the Weka, you see there cross-validation. Cross-validation. This is when your data is not very big. You have very few samples. that you cannot be divided into 2 or 3. So in that case, you are going to partition the data into like, maybe let's say we use 5-fold cross-validation, 5-fold or 10-fold. Let's say 10-fold cross-validation. So I divide the data into, let's say I have like a, and sometimes also we use it even when you have data that's not much, but you can still manage it. Like I have 100 samples. I divide into, this is 10, 10, 10, 10, you know, and go to be in 10 places, up to 10. I have 10 samples in each fold. I call it 10-fold cross-validation. What do? I will use the first 9 portion from 1 to 9. I will use it for training. It means I merge all those divisions into one, making 90 samples. I use for training. I use the last one for testing. And I record the result, maybe 92%. Now, this one I use for testing now will become part of the training. From 1 to 8, which is 80, plus the 10, making 90 again. Then that number 9, 9th portion, I use it for testing. 9th portion, I use for testing. Maybe I got like 82%. I keep doing that. Every portion must be used for testing one time. I keep doing that until I use from 2 to 10 for training. And then I use the first portion for testing. That is 92%. I will now find the average of, I have 10 experiments now. Add them together, divided by 10. That's going to be your result. This is called cross-validation. We use it when the data is very few, or when you just want to have proof of concept. Or sometimes when you divide your data into 2, 70% for training, 30% for testing. You know, I keep this one out totally. I don't use it for the training process. I will now use cross-validation on this to do the hyperparameter optimization. Divided into like 5 portions or 10 portions. It can be 20 portions. It doesn't matter. Just define it in your report. We call it experimental description. Whatever assumption you make, you must make it clear in your report. Otherwise, people will not be able to repeat your experiment. An experiment that is not repeatable stand rejected in academic circle, in research. So those are the 2 types of partitioning method we do have. Cross-validation and also hold-out method. Sometimes, if you are working on a research that somebody did before, then you have to use the partition method they use on their own. Pay attention to this. You may use the other one as additional work, but for you to have a valid comparison with their work, because in AI machine learning research work, we do a lot of comparison. Someone who used the same data set you want to use before, they got 92%. You can do that, you can work on that data again, but you have to use their procedure. They divide it into 70%, 30%. You cannot divide your own into 80, 20, because your validation comparison will not be valid to them. So make sure you follow the same principle they have done. If they use hold-out method, you use it. If they use cross-validation, you use it, because you need to compare your result with their result. However, you may then use additional in your own. Like they use hold-out, you decide to use hold-out and cross-validation, and you document the result, and you discuss it. That is fine. So hope that answers your question. Our medical question from the medical field. So many areas of medical work that really needs AI machine learning. So you are welcome. I wish you all the best. We do a lot of work also in that area. You can check out some of our work. So, and you're always welcome. If you get stuck at any point in time, to be a player, to also guide you.
Thank you very much for that. Thank you, sir.
So I believe those are the questions we have for the day.
Well, sir, thanks so much, sir.
Okay, Doctor?
Yes, thanks so much. I think the last questioner has really spoken the mind of many people, because people are not, they don't really know or the exact position of validation I think the essence of the whole show is testing. And for you to have your testing done, when you develop a model, the essence is to test and get accurate results. But for you to do that, you must train your model. That is first stage, which is the training and testing. But in between the two, you have trained a model and you are very sure that the model is working well. It can test and give us accurate result. But someone somewhere wants to know that, okay, what you have done, can we validate it? By so doing, the validation can come in between the training and testing. You have trained, yes. Then let's see the outcome of what you have trained, which is validation, before the model is deployed, which will be used for testing. Because I've attended some defense where the audience are not really getting the true meaning of validation and testing. I'm just bringing this out because I have also been receiving, let me say, the request that what is the clarification? Where does the validation come into play and the testing? Thanks so much, Prof.
Yeah, thank you very much, Doctor. So the coordinator for that. Yeah, like I said, is validation. What matters most for you to build your model? You see, there are some concepts that are interchangeably used, okay? That there will be no penalty for that. You see, you may not talk of validation at all, and just, okay, I'm doing training and testing. That is also fine. That works fine, okay? So, however, when you divide your data into three, one is training, one is testing, one is validation set. But when you have only two, then that is fine. Okay? When you have only two, this is training and testing only. But when you have extra, then you can validate. But then sometimes when you have your training set, after you train your model, then you want to see how your training set will perform on what it has seen before. I train a model now. I will now give back the same training set to the system, but I will remove the output to see how it's going to recognize what it has seen before. This is where we want to determine, is it having a overfitting or underfitting, or as the case may be. Sometimes, if your system is able to identify your training set 100%, you have to fear. Maybe that is what we call overfitting. It has memorized everything. And sometimes it doesn't perform. But the fact remains, people don't pay attention to the performance of your model on the training set. No one cares about that because they know that either you get 100%, you don't get 100%. What we want is your performance on your training, on the testing set. Because that's what we are going to in your paper, your research output. If some people don't want you to put in your training set performance, they want to see the testing set. But that's the target. Irrespective of what to get in the training set performance can give an outcome of what you are looking for. So that is why some people still look at testing set and validation set as a way of checking that what you have built is working. Some use your site where you are building the solution. When you take it to the client, now they bring another one. They give you another data closer or similar to what they gave you before, but this one they are sure that you have never seen it before. We had that experience with one of our professor, collaborator. He gave the data out in chemistry. He never believed that machine learning can do that work for him. So when the student on the experiment, they got very excellent result. He was surprised. He said, because I gave you the data, I think you manipulated it. He said, okay, Prof, bring in your own data now. You see, and in his own laboratory, he put in the data into the system and he was surprised again that the model was still predicting excellently well. So some people will call that one validation set, because this is done at the delivery side, where the user is going to be using what there is. So validation or testing, no one should be held responsible for using them interchangeably. What you want to do is, you want to be sure that the model you have built is working fine. Either you do it on the side, or you are doing it when you get to the client. Hopefully that clarifies. Thank you very much. all for the listening.
Thank you very
So,
much, sir. I've understood it better now. Thank you very much.
okay, you are welcome.
Oh, good morning, sir.
So I wish, yeah, good morning. You have a question?
Yes, sir. I have a question, sir.
Okay.
Yes, sir. Yes, Prof. I'm Rufai, a postgraduate student from Lee City University. Yes, there's something I want to understand about your last explanation from the question. Yes, is there any standard that guides students, machine learning researcher on how to choose training sets, testing sets, and then validation test? Like the percentage to use, sir.
Okay.
Yes, sir.
Yeah, the percentage depends on like I just explained, the type of validation you want to use. However, there's no standard percentage. That is, what is commonly done is this: you look at your data set, but it's advisable that your training should have more data than the testing, because what you are trying to do is something that is really legendary. You want to expose some data to the system, and later you want it to be able to recognize anything that is similar to it. So the training set usually need more data set. That is why it's very common to have 70%, then 20% for the testing. Sometimes you have 80%, then 20% for testing. Sometimes you have 75, sometimes 85. Some people goes to 90, but I personally discourage 90. 90 is getting too much, and the samples you are going to test it with is too small. But if you have very big data, the data that is huge, because you want the system to work on several years ahead later and then be able to work and get good results. So in that case, you use larger portion, like 70% is very common. So you are at liberty to use 70, 75, 80. This is what I usually recommend my students to do. 75, 70, 80. People goes to 85, 90. I don't like it. It's too much excessive. So between 70, 75, 80, there may be 85. This is okay for you. However, the only time you don't have option on the partition percentage is if you are working on a particular data set that has been maybe published before. Someone work on that data set and they use 70%, 30%. Then compulsorily you must use 70%, 30%, because you need to compare your work with their work. Because we noticed that work got like 80% in medical prediction. And we felt that we can still make this result better. So we now picked up that data set, we start working on it. And we noticed that they use 70%, you have to use exactly 70% like them. And this is how one of the ways we recognize junk papers. You see, when you want to do literature survey, don't waste your energy on junk paper. What do I mean by junk paper? Paper that they just send to people, come and publish in this journal. We have 2 more slots. You pay money. Within 2 days, they publish your paper. There's no research paper you can publish in 2 days. You see, they don't read it. So when you download such paper, go to the experimental description. If they don't tell you how they partition the data, just ignore that paper. Don't even review it, because it's not even supposed to be published. But because no one did peer review. Because experimental description is very important. An experiment that can never be repeated must not be published. So once you read through a paper that you have interest in, you are working on maybe on the same data set. However, they didn't tell you maybe it was 70%, 80%. How did that kind of paper pass through the editorial review? Because that experiment is not repeatable. So I usually tell my students, don't waste your time on such paper, just throw them away, because they are published in junk journals where people just collect money and they just publish anything you write. So we should not glorify such paper by reviewing them. You are making them popular even though they didn't do anything. So this is why it's very important when you are reviewing, look at it. Is it really worthwhile? That's why I usually recommend to my students to go to like Elsevier, Springer, some of the very popular database that you know that before you publish there, you must have. There are some journals also that are not in Elsevier, but they do peer review. See, repeatability of experiment is very, very important. So this is the only where it may be compulsory for you to use the same percentage they use for their experiment. You have to use it so that you can compare your result validly with their result. If there's nothing of such, you are using your data for the first time, you are at liberty to choose the kind of partition, either 70, 75, 80. So, or you want to use cross-validation, as the case may be. I hope that clarifies.
Yes, sir. Thank you so much, sir. I really appreciate that explanation, sir.
You are really welcome. I wish you all the best. Thank you very much also. Thank you everybody for the attendance. We always encourage us. Let us spread the message also to other people. We want as many as possible people to take benefit of this kind of AI machine learning democratization, that we want people, the power is so huge of the power of AI and machine learning cannot be overemphasized. So we want us to also benefit others to be able to have access to such interesting learning platform. So wishing you all the best, everybody. Thank you very much again. So hopefully we'll be communicating us over our channel. For those who are not yet on our WhatsApp group, it's always very important. So that will be updating us when we are going to have class. Sometimes if I travel, maybe we may not be having classes, but everything will be announced in the platform. So kindly, the coordinator, please make available for us the link to the platform in case for those people who are here to join the WhatsApp group. So thank you very much, and I wish you really all the best. Thank you for the attendance. And another information also before I forget is for those people who may be having problem with Zoom. I know Zoom is a little bit heavy. So starting from today, we started live streaming our presentation on YouTube. So I believe the link has been shared in the platform. So for those that may be having problem with Zoom kept going out and in, you can also join us live on the YouTube channel so that it will be lighter, hopefully, so that you'll be able to join us without any network disadvantage. So thank you very much all, and I wish you all the best. You are welcome. Yeah.
Okay.